such as space travel. Typography is not always simply an aesthetic decision, but it is a tool. This will be her first presentation for TUG conferences. And the title, From Neurons to NASA, a brief tour of the brain, font psychology, and implications in spaceflight missions.
Hi, my name is River Temple. I'm a third-year biology student at George Mason University, and I'm very honored to have the privilege of sharing my research with you all today. I really hope that my project can raise some questions and get you thinking about the role of typography outside of design, because today I would like to talk about typography and space science. So the title of my presentation is From Neurons to NASA, a brief tour of the brain, font psychology, and implications in spaceflight missions. Let's talk a little bit about the brain. The brain is like a factory. It's responsible for pretty much most things that you do, and the way that it works is it contains a massive network of neurons that communicate with each other through electrical and chemical signaling. This is what enables you to remember things, move around, and understand what you're looking at, and all the other good stuff. But in order to do this successfully, the brain has specialized compartmentalization. So each segment of the brain is responsible for unique things, but they all work together to complete tasks. Then there is rapid information processing, and that is how your brain handles a steady feed of information, where it uses your memory centers and context to filter out unnecessary information and predict what is going to happen next. And some of the regions involved in successful reading. This can be quite a large topic, so I've boiled it down to the things that you really need to know. The first step is that your eyes capture information. That can be lights, rough shapes. That gets sent to something called the fusiform gyrus, where that information is analyzed. And depending on how it's interpreted, different modules activate. So for example, if it looks like a face, there's something called the FFA, or the fusiform face area. Or if it looks like a character or a letter, the VWFA, or the visual word form area, gets activated. Which is more relevant with today's presentation. The gyrus then takes all that information and sends it to your brain's memory centers, like your hippocampus, and the live processing feed gets rapidly interpreted based on everything you've seen or known in order to identify it. This all happens within a span of milliseconds, all the time. So how does space travel impact the brain? Well, the first point that I'd like to look at is something called superimposed cognitive fatigue. Basically, your neural feedback builds up and lags, right? Like a computer. If you have a lot of tasks going on, it's all going to be completed slower. The second point is reduced cerebral perfusion, or cerebral hypoxia, which lowers function further due to lack of oxygen. The third point is gravity-induced loss of consciousness, otherwise known as GLOC. I'm sure a lot of us have seen those space movies where an astronaut is in an emergency and they have to get control of their vehicle and they start passing out. That is called GLOC. It is quite literally losing consciousness from gravity. And the last point is neuroplasticity, which is your brain physically rearranging itself, especially more dramatically when it is exposed to different conditions for long periods at a time. And a lot of these might seem pretty negative, but they are really important. These are like your body's armor response to handling all these changes. So you really need these things. So delving a little further into neuroplasticity, some things that can happen are your cerebral spinal fluid volume can change, the central sulcus of the brain can narrow, and the actual matter of your brain itself can shift around. And theoretically, we can assume that this probably affects your reading and comprehension because the anatomy of your brain is physically changing. So here we have some images from the New England Journal of Medicine that showcase 94% of analyzed astronauts from long-duration missions had their central sulcus narrow, versus only 19% in short duration, and it was usually less noticeable. So the period of time that you're exposed to these conditions does really matter. Talking a little bit more about white matter also, there's something called the arcuate fasciculus, which is a connection for the brain's language centers. You have your inferior longitudinal fasciculus, which is linking to visual processing, and these two work together. So the stronger that they're connected, the better that you can read. And dyslexia is what happens when you have bumps in between them, right? You can think of it like there's a highway between the two. You start at one, the other is your destination. If there's traffic, it takes you longer to get there. Pictured here is the Broca's area and the Wernicke's area. The Broca's area is responsible for language interpretation, and Wernicke's area helps you with language output and understanding. So, how exactly do you get reading out of this? Well, words are first broken down into something called phonemes. Phonemes are the combination of letters that form distinct sounds in words, like the letter S and H creating the sound sh. Sh, in that case, would be a phoneme. These phonemes are assembled to reconstruct word phonology in the left inferior frontal cortex, but the letters themselves are actually converted into phonemes in the left supramarginal gyrus. Basically, all you need to know about this is it's bidirectional, so it flows between the two to help you both understand language and produce spoken language yourself. Now, how are fonts registered by the brain? A lot of studies use something called ERPs to analyze how your brain responds to things. So ERPs are these little nodes that are placed around your head, and they measure the voltage and polarity of your brain when you are reacting to stimuli. So in this case, it's written stimuli. It just shows how fast it takes you to do things and where they happen. And font disfluency is the subjective difficulty of understanding text within a particular font, right? So a font that's in cursive and calligraphy is harder to read than a standard sans serif font. Manipulating these fonts has actually been proven to slow down ERPs. So essentially we've gathered that fonts that look less like what we're used to in terms of characters do physically take us longer to read, which is important because soon we're going to be talking about how fonts and design and typography goes outside of just aesthetics. So first, let's delve a little bit more into font psychology. Fonts are very intentionally designed, right? Font design, it's an art form. One of the biggest driving forces behind art is emotional representation, and this is not any different from that. Think about if you were to see like a super geometric sans serif font that's using a lot of angles in the character design. You're probably going to look at that and assume that it's technical, modern, and maybe even futuristic. And, well, why is that? A lot of it is cultural association over time. It's led to our brain interpreting certain design choices with themes, feelings, and even places, and that's what makes company branding so successful. If you can get a customer to associate a font with your brand, you immediately have a memorable experience, right? That recognition really matters. And in the bottom right here, we have the Open Dyslexic font. This font is designed to be more bottom heavy, right? So that characters that mirror each other are easier to discern. So if you look at lowercase b and lowercase d, you'll see that the lowercase d does have that extended line, and even just small differences like that can help your brain interpret it faster if you have something like dyslexia. Now, NASA's history with typography is pretty cool. The first example here is Futura. It is a sans serif font that was created during the Bauhaus time. It has been used for a lot of different things, entertainment, political campaigns even, and it's associated with modernity and progression. It was coined the type of today and tomorrow. And NASA has used it here in this example on the top left. This is a replica of the plaque left on the moon by the crew of the Apollo 17. This specific piece was transferred by NASA to the National Air and Space Museum in 1975, so it's been there for a hot minute. It's really cool. The second image is the Challenger space shuttle, which is using Helvetica. Helvetica being a sans serif font named from where it was created in Switzerland in 1957. It's very balanced. The lines going both directions are very even and clean, very legible, and it is used also for signage and things like that. The examples that I talk about here come from the brand guidelines. I believe these guidelines are specifically from 2024. However, some examples were harder to find on the actual website, but I'm going to go over them anyway. So Inter, the first example here, was released in August of 2017 by Figma employee Rasmus Andersen. It was designed for computer interfaces initially, and now it's used for marketing and signage. It has this like tall X height, so it's really easy to read even at smaller sizes. Public Sans was based on Lieber Franklin, and this was actually developed by the government for government-friendly branding by the US Web Design System team. This was released in 2019, and it's supposed to be neutral and clear. DM Mono is a monospace sans serif font by the Colvin Foundry. It's for like code, technical labeling, and like numerical clarity. So all the like number stuff. And this specific listing, like I said, is from 2024, which does also include some information on the legacy typefaces like Helvetica and Futura. But the three that I went over are the ones that are most commonly seen. And then you also have Arial present there. The information on this slide is really cool. It comes from a NASA display standard manual for uniform UI design across interfaces on spaceflight programs. So they want everything to look really clean, and they want to have this like guideline for how you design these things, right, for usability. So some rules here are that the text has to be sans serif, and you have to be able to tell what each character is super easily. It needs to be a fixed width font for numerical and tabular information, just to keep things technically clean and modern. The character height needs to be easily legible, and colors are used symbolically to tell the crew members what the information means. So red is for highest alert, yellow is secondary caution, blue is advisory information, gray is if your information is temporarily unavailable, and cyan is if it's completely missing or stale. And another interesting fact here is there's also a rule stipulating flashing text for immediate crew attention. It's reserved purely for that. And for standard frequency, it's 0.8 hertz, and for super high priority, it's 3 hertz. But the super high priority stuff needs to alternate between 3 hertz and 0.8, because if it's just super fast all the time, it's going to be really hard to read. It's quite an in-depth manual, and it really makes you think about the usability factors of these UI interfaces. Some things to consider is that astronauts really need clarity on whatever they're reading, right? They have a lot to do in not a lot of time, and it's really serious stuff a lot of the time. As fun as it is to go up there and just look at the planet from miles away, you're a very responsible person. So font is really not just an aesthetic choice. It becomes a tool in your arsenal. And when you consider how the brain changes in these conditions, whether it be stress or the time constraints or just, even being in different gravity, it all slows down your neural feedback, like we'd mentioned earlier. So you really need to think about the design choices that you're making here. Some future things that I'd like to explore in this topic. The main one would be if the open dyslexic font is beneficial or relevant for emergency UI on space missions, right? If it was designed specifically for comprehension and discernibility between characters in a situation where time really matters and you may not have a lot of it, the faster you can read something to get it done, the better. And I would also like to explore further on how these different gravitational conditions, whether it be macro gravitational like centrifugation or microgravitational in space, or when you return back to Earth and, that neuroplasticity, your brain changes every step of the way. I'd like to look more truly into how that works. How does it affect reading, and for how long do these effects last? And also, how could the world work together to curate fonts intended for spaceflight that represent larger populations? Could this be a discussion for different characters, like Arabic or other script languages? And can we find a perfect solution for design and apply it internationally as a standard for legibility? I would like to thank Jennifer Claudio. None of this would be possible without her. She saw something in me and gave me this wonderful opportunity to really delve headfirst into something that I ended up becoming very passionate about. And I'm super excited to see what else is in the works for this project. And I'd also like to say thank you to Stephen West, who is someone from my personal life. He was my soundboard for a lot of my research to make sure that I wasn't just saying a bunch of science jargon and it was actually, legible and made sense to a large population. And sometimes I just need that. So that's been really awesome. Thank you for your time.
Interested in the cognitive aspects of perception and reading. And I've noticed in your talk the same kind of trend that we observed in the general literature, which is that Nowadays, most of the activity involving the cognitive aspects of reading are focused on font shapes and not so much on text as a whole. So I was wondering if you are also interested in studying the impact of not of fonts themselves, but on the arrangement of text on pages. For instance, what about interline dimensions, whether justification is a good thing or whether a ragged disposition would be preferable for astronauts and stuff like that. So everything not involving the shape of characters themselves. Thank you.
I think that's a very interesting question. And honestly, I started kind of thinking about that myself during this presentation, but you are completely right. A lot of the research on how font is read is definitely on font disfluency. I do find it very interesting. I didn't get to delve into it too much given the focus of the content that I was finding and the research that was like pretty available to me for my topic, but that's definitely something that I'd like to look into more. And I do think that that is an underrepresented aspect of the discussion.
Okay, now, thank you. This is not from, okay, this is Boris Weissman. It's not from the chat, it's from me. As usual, I have a question and a very short remark. My question is this. You mentioned colors, red, yellow, and so on. A lot of people have color blindness, actually, considered, and we have now standards about colors, luminosity, and so on. And I have an impression that the NASA guidelines have been written before the research have been done or used. So do you have any comment or any intention to go into the color choices by NASA and whether it's optimal and whether they should change it because a lot of people just don't see the colors like they think they do?
I also thought about that myself because I am slightly colorblind myself. And you're right, it's definitely something that I don't think was considered when the manual was written. I think it might have to do possibly with eyesight requirement standards. I didn't look too much into it yet, but I do believe that there are certain rules that you have to like have criteria wise for your vision to be able to go on these missions. And I definitely want to look further into any policies regarding regulation on color blindness. But if there is more openness in that area during space travel, I absolutely think that there needs to be more consideration for inclusivity within the colorblind community and changing, even if it's just putting a little comment under or using symbols instead, something that could be understood by everyone. That's a really good question.
Yes, thank you. Maybe we should talk offline about this. And a very short remark, great presentation, thank you. And when you go to last slide, I understood that you are a student of Jennifer Claudio. Many people here know Jennifer. She had been in many TUG meetings, and I just want to shout out to her. She is always welcome, and her students are always welcome in this community.
Yeah, Jennifer is awesome. Definitely shout out to her. I mean, none of this would have been possible if it wasn't for her reaching out to me and inviting me to this whole conference.
And then, like, for everyone who doesn't know, Jennifer was the one who drew this logo on all our t-shirts and mugs and such, so that was her.
Thank you. This is Carl. Thank you, River. It was a great presentation. And I wanted to just say there's a lot of other dyslexic attempts at font designs to help dyslexics nowadays. And seeing a comparison between Open Dyslexic and some of the others could be interesting. And I wondered for you, is this an area that you're going to be able to pursue in your academics going forward, or are you on to other things?
I would love to. I think right now
given that I'm still an undergraduate student, it's just completely going to be on who wants to be in the master's program, because there's a lot of different things that I'd like to pursue, but this topic is definitely near and dear to me.
Sorry for grabbing mic again, but it just happens that I'm a professor at the same university that River is undergrad, so I need to think about this myself as well.
I was going to ask whether or not you knew her.
It's the first time I see you. But
Okay. If there are no more questions, oh, here it is. Harish, all right. Here's the.
I actually have a short remark. Watch and learn, Boris. No, I'm just kidding. I'm glad that I'm not the only undergrad student here. I'm very happy to see that, and also a very unique presentation. Thank you, River.
Thank you.
Thank you to everyone who took time out of their day to hear me talk about this today. And it's super awesome that there's other undergraduates. I think this is a great opportunity for really everybody.
Okay. All right. If that's all, let's thank River.